Alright, so for Chapter 8, we're just going to get into some integration stuff. And one of the first things that we're going to talk about is just fitting integrals to basic integration rules. And what that means is that we have sometimes, and this sometimes can be a little bit challenging topic. The homework questions that I have, I don't feel that they are overly challenging. But it's when we have something that may not be blatantly obvious, an integration rule, or that fits an integration rule, but we can do some kind of maybe algebraic manipulation to be able to rewrite it as a basic integral rule. Okay, so let's just look at one here, just as an example, and this is going to use a lot of the integration rules that you're going to use here are going to be like UDU substitution and inverse trig. So let's look at an example of both of those. So I've got 4 over x squared plus 9. I'm going to take the integral of that with respect to x. So just in looking at this, I don't know exactly how to take the integral of this written like this, but I can factor this 4 out and rewrite this as 1 over x squared plus 9 dx. Okay, I still don't know how to integrate 1 over x squared plus 9, but if I rewrite that as 1 over x squared plus 3 squared dx, now I have an arc tangent, right? Because I've got an x squared plus a squared, right? And so then I have 4, so the integral of that using arc tangent is 1 over a, so 1 over 3. Arctan or inverse tangent, ever how you want to use it, of x over a, which is x over 3, right, plus c. So if I wanted to clean that up, I could say 4 over 3 tangent x over 3 plus c. All right. So again, you may want to recap those rules for inverse trig and UDU substitution with like logs before doing this section, because then let's look at one that's a very similar integral, but instead is 4x over x squared plus 9 dx. All right. Again, I'm going to factor out the 4. Now I've got x over x squared plus 9 dx. However, I don't necessarily have, any kind of inverse trig here, so I need to start thinking about maybe UDU substitution. So if I let u equal x squared plus 9, then du would be 2x dx. Let me erase that and fix that. 2x dx. All right. If I divide that over, I get 1/2 du equals x dx. So I can replace my x dx. And so my integral is now 4 times the integral of 1/2. Let me rewrite that so it's a little bit cleaner. So I can go ahead and pull the 1/2 out front. So I'm going to go ahead and pull the 1/2 out front just for simplicity. So instead of 4, it would become 2. And then I have du over u, or you could say 1 over u du. Well, of course, that's just the natural log of u, so I have 2 times the natural log of the absolute value of u plus c, and then I can just replace my u with my x squared plus 9. Okay, so this is really it as far as 8.1 and what needs to be covered, because the homework is just identifying which trig identity it closely matches. And all you're kind of trying to do is think about how you could rewrite it to set up and look like one of the other trigs or one of the other integration techniques. All right. So this actually does conclude section 8.1. We will get into a few more integration techniques before the end of the semester. But if you do have any questions, please feel free to email me. And as always, have a great rest of your day.